This is 3.3b notes, measures of dispersion. So we're still looking at measures of dispersion, and we're specifically still looking at variance and standard deviation, but we're going to use a different method to find the variance. Okay, remember standard deviation is the square root of the variance. So if it asks for standard deviation, you find that by square rooting the variance. The sum of squares method, so we have the sample variance, which will be looking at the same formula, or the same letter, which is s squared. Sample variance s squared. But for the sum of squares method, you're going to sum a bunch of squared values. So we have the sum of x squared minus the sum of x then squared divided by n all over n minus 1. Okay, so notice that that n minus 1 piece still comes into effect. Then we have the population variance. Okay, very, very similar formula, but it's a different symbol, sigma squared now, lowercase sigma, little o with the tail in the front. And this time, it's the sum of the x squareds minus the sum of x then squared all over n, or over n all over n. Okay, so notice the bottom part is taking into account the correction factor for samples and the no correction factor for population. That's important. And it has, looks like a very complicated formula, but really it's not that complicated. We need the n, that happens twice in each of these formulas. That's how many data points. That's easy. We need the sum of x, so add up the data points. And we have the sum of x squared. So we would take the square of each data point and add them all up. Okay, so this is actually probably the more popularly used way of getting it, the variance, because you don't have to find the mean. I will say for the our class, the first way we learned is the way we'll use most often, because most people understand that the easiest. But this is actually a more popular way in real statistical world, because you don't have to find a mean. So we need two sums, sum of x squared, and then we need n. The sum of x, I add up my x values. 3 plus 3 plus 5 plus 6 plus 8, 25. The sum of x squared, so I took the square root of each one, and I'm adding them up. 9 plus 9 plus 25 plus 36 plus 64. And then n, how many are there? 5. Okay, it doesn't matter whether it's a sample or a population at this point. That part is exactly the same every time. This is sample data though. So when we get to our formula, we're using sample variance, s squared. Okay, so that one says the sum of x squared, so 143, minus the sum of x, 25, then squared, divided by n, all over n minus 1. Okay. So the top part, you would type into the calculator exactly how it looks. 143 minus 25 squared divided by 5. Exactly like that. And you would find 18. The bottom is 4. 5 minus 1 is 4. And then you type that in, and so you get a sample variance of 4.5. Boom. Done. Notice how quick that was. We didn't have to find means. We didn't have to find the deviations. We just took the data values, squared them, and then plugged it into the formula. It's pretty easy. If you know how to use, if you know the formula, makes it really easy. Next, we have population data, but we start off exactly the same. I need to find my sum of x, the sum of x squared, and my n. So my x is 1, 5, 7, 8, 10. my x squareds, square each one. If you need to use a calculator, square it, that's fine, use it. Okay, add them up. So I get 31, add up the x squareds, I get 239. And how many are there? In this case, there happens to be 5 again. Remember, how many data points, right? Okay, so this time it's population data. So that would be sigma squared. I take my sum of the x squared, 239, minus the sum of x, then squared, so 31 squared, divided by n, all over n. So if you wanted to, you could do it step by step. 239 minus 192.2 over 5. Then you'd subtract those two and divide by 5, and you would get 9.4. Okay. Notice there's a lot of calculating, and unfortunately without a video or being in front of you for this, I can't show you how to do it. So, but practice, please practice with your calculator. I'm giving you what your results should be so you can practice it. Okay. So, example 3 says, find the range, mean deviation, and standard deviation for the sample data. Okay, so a little bit of review of 3.3a. You need to know that. So range, I'll do that one first. Well, I'll set up a table. And this time I'm actually going to use the old method because you find the mean already. Might as well use it. And I have to find the mean to be able to find the mean deviation. So 5, 8, 10, 12, 6, and 7. I'm going to find my mean over here. And you can kind of see why, if you're just going straight to standard deviation or variance, remember standard deviation is the square root of variance, this method takes a little bit longer. Okay, so I get 8. So -3, 0, 2, 4, -2, -1. Make sure they add up to 0, which they do. That's how I know I got it right. Okay. So I'm going to fill out my table. So I take the absolute value of each one. And then the last thing, I'm going to square each one. Notice I'm kind of simplifying what we did last time all into one table, doing all the work at once. So then I can just go straight into the answers. So first, range. That is the highest number, 12, minus the lowest number, 5. So we get a range of 7. Next is mean deviation. That is the same as mean absolute deviation. Okay, so imagine there's the word absolute. That's the same idea. Mean absolute deviation, mean deviation. Okay, so I add up my absolute value things and divide by how many there are. Oops, sorry, there's 6. Okay, and so we add them up. You get 5, 9, 11, 12, so 2. Mean deviation is 2. It doesn't ask for this, but to find the standard deviation, I need the variance. So this is S squared sample variance. So I add up my squared values, divide by how many there are, -1, because I have the correction factor for sample variance, only sample variance. Okay, so I add all those up and I get 6.8. Then I get standard deviation. That's actually what it was asking for. So don't forget, if you're asked to find standard deviation, you have to find variance first. So that would be S, which is the square root of variance, which is 2.6. Square root of 6.8, 2.6. Okay. Unfortunately, this example 4 accidentally on the first page, but it goes to the second page. It says find the standard deviation of the population using the table method. So that's the one I just did in this example. This is called the table method, where we find the mean and square, or find the mean and then find the deviations, square it, and do all that. And the sum of squares, which is the new formula we just learned. Okay, we'll kind of compare and contrast those real quick. You'll see that you get the same answer regardless, but we'll talk about how to find this. Okay, one important thing is right now we're dealing with population data, so you have to pay attention. Which formula are we using, right? So to use the table method, this is why this one is not used as often. Okay, so we have to find the mean. Then we fill out the whole table. So my mean, I add them all up, divide by how many there are. I'm just telling you the answer is 9. Save some time because this is actually takes a while. Okay. So then we have to subtract each thing. Make sure it adds up to 0. That's how we check, which it's 14 minus 14, so that is 0. So now I square each one. Okay. Then my variance, once again, it asks for standard deviation, but we have to find the variance first. It's population, so I use sigma squared, is the sum of all of these numbers divided by how many there are. 1, 2, 3, 7. Okay, so that's 184 divided by 7, which is 26.285. Okay, so square root of 26.285 is 5.1. That's where I got the 5.1 from. So that's my final answer. Okay, so that's the table method. So I even cut off some time because I gave you the mean in this case, where you normally have to add them up, divide by how many there are, so that takes a few seconds. Then you subtract each value, then you square each value, then you add them all up, divide by how many there are to find the variance, and then you square root that to get the standard deviation. The sum of squares method, so using the same exact numbers, so we should get the exact same answer, which you see that we will. So 6, 2, 10, 19, 12, 5, and 9, those are the numbers. And then just square each one. Using a calculator if you need a calculator. I know not everyone knows what 12 or 19 squared are. Okay. Then we find our three sums. Sum of x squared, and the n. How many there are. So I have 7. That one's easy. Sum of x, add all of these up. You get 63. Sum of x squared, add all these up, you get 751. And then we just plug into that new formula. So sigma squared, because we're talking about the standard population, standard deviation, but we've got to find variance first. So 751 minus 63 squared over 7, all over 7. Okay, when you type that in, you should see a familiar number. It should come out to that exact same value, 26.285. Then my variance, I square root to get standard deviation. So standard deviation is just sigma, square root of variance, and I get the same answer. Okay, so notice, less steps. If you just need this, if you're finding mean deviation, you're already having to find the mean, might as well use the table method. So in this chapter, the table method is pretty helpful. But if you use sum of squares, you just square each number, use a calculator, add them up, and plug into the formula, and you got your variance, square root that number, and you got your standard deviation. It's less time, less steps. Okay, so that's the sum of squares method. Make sure you do your 3-sentence summary.